Good morning, everyone. Thank you, Dr. Shilin, and distinguished guest. It's really an honor and pleasure to be here. My presentation is in actually two parts. The first one is I'm talking more, putting my Intel hat on, and we'll be talking a little bit about the 6G objectives, the visions, and some of the research areas. And then the second part is about me putting as my 3GPP as a chair hat and talk a little bit in terms of 6G planning, timeline, and what's happening within the 3GPP. Not sure. Okay, thank you. So I think President Venku talked about this, about the evolution from 4G, in the previous generation. So the evolution from 4G to 5G to 6G represents a significant leap in wireless communication capability, driven by the advancement in speed, latency, connectivity, energy efficiency, and spectrum utilization. 4G network revolutionized the mobile internet, while the 5G was mainly focusing on the vertical industry, such as healthcare, transportations, and manufacturing. 5G network supports ultra-low latency and massive connectivity, unlocking the potential of autonomous vehicles, remote surgery, and smart factories. Each generation builds upon success and challenges of the predecessor, pushing the boundaries of what is possible and shaping the future of connectivity and digital innovation. With 6G, we anticipate the new area of service and platform enhancements, ushering the novel use cases and further propelling the march towards the mobile connected intelligence. To realize the full potential of 6G, a set of ambitious technology objectives has been outlined. At the forefront is a digital world experience, considering, for instance, the realm of augmented reality and the virtual reality, where 6G will enable seamless integration of digital overlays into our physical environment. 6G aims to deliver high-speed, high-capacity network capable of supporting immersive multimedia experiences, holographic telepresence, and cloud gaming. Sensing and machine intelligence is an important objective, digitizing the real world. Through connected sensing, intelligent systems translate analog information into data, helping us identifying objects. Knowing where we are, hear everything, and even feel, taste, and smell. Sensing can lead into an augmented reality where all our senses becomes digitally enhanced with new sensory devices that make every day better. 6G networks goal to offer ubiquitous computing and communication capabilities. Everything, everywhere is connected. Universal connectivity enables us to collect, store, move, analyze large data sets, enabling the design and delivery of incredible innovation business model, products, and services. Embracing cloud-native principle, 6G aims to create an agile, scalable networks capable of deploying and managing services dynamically. By integrating edge computing capabilities, 5G extends computational resources closer to the users and devices, enabling low-latency application and real-time processing. Enhanced programmability empowers operators and developers to customize network behavior, optimizing traffic flow and innovation of the new services. However, amidst these technological advancements, sustainability remains a paramount concern. Efforts are underway to design energy-efficient architectures that minimizes carbon emissions and reduce the ecological footprint of 6G network. ITR has completed IMT 2030 use scenario document. It mainly consists of extending the three key pillars of 5G around enhanced mobile broadband, URLLC, and massive machine type communications. And on top, it adds three new integrated sensing and communication, integrated AI in communication, and ubiquitous connectivity. Various research alliances have been working to define 6G use cases and regional of global interest. I think Dr. Ed talked about Next G Alliance. So what you see in this slide is some use cases from Next G Alliance as well as the Hexa Europeans project. Many use cases are derived from the 6G technological objective that I talked in the previous slide. The 6G use cases helps in defining the different technology and research areas of interest. Sustainability remains a focal point of the research, with the efforts focusing on developing energy efficient hardware and eco-friendly network architectures that mitigate environmental impact of 6G deployments. However, as you may know, that sustainability encompasses much more than energy saving and reducing carbon emission. Sustainability involves adopting a holistic approach that takes into account entire life cycle of the products and systems. The sustainability design principles consider factors such as choice of material, product durability, recyclability, and ease of repair. On 6G RAT, 10 to 24 gigahertz massive MIMO, seamless TN and NTN integration, which started in 5G, will continue in 6G. Service-aware transport, confidential computing, post-quantum computing are another technologies areas of interest. Prior to 5G, mobile cellular system has evolved independently of the cloud computing. The mobile network architecture has traditionally focused on communication services. 5G started the convergence of mobile communications and cloud computing by defining what we call as a service-based architecture using for the 5G core system, which involved to enable the network function virtualization and cloud-native network functions. As cloudification of 5G mobile networks, 5G system also introduced edge computing. The 6G network can be envisioned a vast array of sensors, users, applications, and services that will both produce and consume vast amount of data. The data will pass through various jurisdictions, business, and geopolitical domains. In addition, the 6G system will envision to provide a cloud framework that works in tandem with 6G communication system. This enables a distributed applications to be deployed using resources of multiple private, public, and hybrid clouds. This is transforming the today's wide area network to wide area cloud. In 6G, wide area cloud means a ubiquitous computing will allow the workload to be distributed across among the devices, network nodes, and the data centers. This will enable many benefits such as processing massive data close to the source to minimize data transport, leveraging specializing computing capabilities to improve performance, and adapting to network dynamics. In addition to communication services, computing and data planes with a dedicated computing and data management functions may be introduced into the cellular network. Now, in the realm of the potential 6G research area, several key focuses emerges. Those encompasses innovative network architecture aimed at creating adaptive and intelligent network by leveraging cloud native and AI native principles. Advanced security and privacy solutions are crucial, addressing the dynamics and interconnected nature of 6G network to safeguard user data and counter cyber security threats. Moreover, optimizing the hardware and software integration is imperative, ensuring seamless interoperability and resource utilization while enhancing performance and scalability. Next generation connectivity technologies, including dynamic spectrum access, promise to enable ultra high speeds, low latency communications is essential for 6G networks. Tailored vertical and private network catering for specific industry and use cases, delivering dedicated and secure customizable connectivity solutions. Additionally, revolutionary RAN and core network infrastructure featuring virtualized RAN and open RAN initiatives facilitates a flexible, scalable, and cost-effective deployments. Like previous generations, standardization is essential and critical for the success of 6G. In the middle, what you see is various technology and the research organizations that has been already working on the various use cases for 6G. Today, industry is working on pre-standards, but what we see is these works converging within the 3GPP and other standards organizations. Open implementations, open interface, and architecture would play an important role in 6G standardization process. 6G standards development would involve broader participation from different industries, segment, including cloud industry and vertical industry inputs on the use cases. In addition to these, the expanded ecosystem participations bring a new set of questions and challenges that industry and government needs to work together to resolve, including information security regulations, radio equipment conformance, system integration, and interoperability. The journey towards 6G is not merely a technological endeavor, but also a collaborative endeavor driven by global standards effort. We need everybody participation and contributions to create a globally unified 6G standard. I think we already know about this. The ITR timelines for IMT 2030 has been defined. So based on that, what we have within 3GPP, a agreement on the first use cases aspect of 6G timeline. In March 24, 3GPP agreed on some additional consideration for 6G timeline, and we are expecting to discuss further about Release 21 in future meetings. So the key agreement so far has been that we're going to start with having a 3GPP workshop on stage 1 IMT 2030 use cases, which will happen in May 24. And I'm going to talk a little bit more about that. Then there will be a 3GPP-wide workshop to kick off the Release 20 study items in SA and RAN groups, which will happen in March 2025. So within 3GPP, it's now consensus that the work will happen in 2 releases. The Release 20 will be focusing on 6G studies, while Release 21 will be the normative work for 6G. The Release 21 is expected to be delivering with a single drop, it is a single code freeze. The stage 1 workshop of IMT 20 use case will happen from May to 10th on Rotterdam, Netherlands. And the first workshop on TSG-wide will be happening in, as I mentioned, in March 2025. The details are still being worked out with the TSG chairs, but we're going to have a plenary meeting scheduled subsequently in the same week. The study on 6G is happening in Release 20. I'm going to talk a little bit more. And the normative work for 6G is in Release 21. Now, the Release 21 timeline is to be decided no later than June 2025, June 2026. However, it was established that ASN1 and Open API freeze date is no earlier than March 2029. So for Release 20, we're going to be having a 2-track. One is about the 5G advanced track, and another one be on the 6G study items. The 5G advanced track would be in 80 months, assuming no delay for Release 19. And what you see on the screen are the various stage 1, stage 2, and stage 3 freeze timelines, along with the ASN and Open API freeze for the 5G advanced track. Within Release 20, we'll also be having a second track on 6G study items, where the 6G study item for SA1, which is about the use cases and service requirements, will come for an approval in September this year, and that objective is to complete the study by March 2026. The SA2, which does the system architecture, the study will start in June 2025, and the other working groups will follow up after a quarter or later. These studies can continue after this 5G advanced stage frame line, and what we expect is the architecture study in SA2 will be completing somewhere in December or March 2027. This is just a pictorial representation of 3GPP SA Release 20 timeline, which I talked about in the previous slide. Little bit on this stage 1 workshop on IMT 2030 use cases. There has been quite a bit of an interest around that, and this will be happening in Rotterdam, Netherlands. And the objective of this workshop is basically to bring 3GPP closure to all the ongoing initiatives in various global and regional research organizations and MRPs regarding the 6G use cases. This collaboration is of particular interest as SA1 embarks on defining requirements, use cases on 6G in Release 21. So what we expect from this workshop is what you can see, and this is my last slide, is about, you will see that we have 3 tracks. One about the first day would be focusing on the operator and verticals. So we would have presentations coming from the GSMA and GMN followed by several MRPs, which are part of the verticals on automotive industry, multimedia, satellite, public safety, and wireless broadband alliance. Second day would be focusing on the research alliances. From Japan, we have B5G Promotion Consortium, Korea 6G Forum, China's IMT 2030 Promotion Group. From India, we have Bharat 6G Alliance, America Next G Alliance, and from Europe, 6GNS. And the last day is basically focusing on driving the synergies between ITUR and 3GPP. So for more interest, please take a look at the document 456 that provides a little bit more details about that. This concludes my presentation. Thank you very much for your time.